Welcome to another session which is on deep learning. So today we are going to learn about deep learning and also artificial neural networks and difference between machine learning and deep learning, why it is required to go for deep learning, all such concepts we are trying to cover today. Along with that, I will also going to demonstrate you a project. So how exactly real-time projects work in companies and also all those things. Today we are going to do that. Mostly, first of all, I will cover today a deep learning introduction and then artificial neural network demo. Once I complete that, later I will also show you the way how to do project. Okay, the real time. I mean, in what way you should do the project, and this is all going to cover today. Okay, without any further delay, let's get started. First of all, we all know that machine learning, what exactly it is. So the basic difference is we know machine learning is able to, we want our machine can think and can learn from the patterns without being explicitly programmed. And what is the definition in that case? What is deep learning means? Deep learning is, if you can see, it is a subset of machine learning. But here in deep learning, what exactly it is going to use is multi-layered neural networks to find the complex patterns which are there in the data sets. I'll try to explain it very clearly. For example, let's have a picture. Um, just give me a second. I have the picture. I will show you difference between machine learning and deep learning. Yeah, this is a picture. Hope it is visible to you. So this picture, if we can see, what is the basic difference between machine learning and deep learning is. In the first case, machine learning is there. Here, let us say I'm having a data set and my goal is to predict to whether the particular image or any data point is either car or not a car. Okay, this is what exactly I'm willing to predict. So for that prediction, what I need in machine learning means we already discussed about machine learning pipeline, right? So machine learning involves historical data forward followed by feature engineering. After that, it has to divide to two step train test split. So we have to divide the entire data into two halves. 80% goes to training, 20% goes to testing, let's say. And machine learning algorithm is being implemented on the training data, and then evaluation has to happen on testing data. Once we figure it out, if there are no bias, no less bias and less variance, and bias variance trade-off is there, then we can fix that machine learning model and it is all set to get the new results. This is what we already knew. But if you observe in machine learning, what exactly we are doing is, for example, if I wanted to predict a given input is car or not car, features are really important. So this feature extraction is performing by by us, like by a data scientist. We can say that this person is a data scientist, and this person is identifying all the features which will help machine to understand, or which will help machine to learn what data points are can classify an input image is a car or not car, correct? So and then those features are I mean in if you remember, in machine learning we use x and y. X represents all the input features, y represents the output feature. So those selection of input features and output feature has done by data scientist, correct, or machine learning engineer. So they decided what are input features and what is an output feature, which has to go to the machine to think and learn a pattern from the data. That is what it is happening here. If features are different, let us say the x values are different and y values are different, y value is different, then accordingly the machine will learn and will think and will try to predict whether a data point is car or not. This is what happening in machine learning. It is really important. The feature selection has to be done by um, you know a data scientist manually. But what happens in deep learning? So in deep learning, why the deep learning concept has come means it is really simple to understand. For example, let us say if we are dealing in unstructured data means it can be image data set or textual data set or voice data set which does not have any structure. That's why it is called as unstructured. If we are dealing in unstructured data, it is really difficult to capture the important features behind it. Correct. So for example, how do we decide this image is a car or not? Because if we focus on the edge, if we focus on the edge, so if any image has this edge, this is one of the reasons or one of the ways to classify an input image is a car or not. A human eye can easily do that because we do have a lot of neurons in our brain, which will really help us to detect or to identify features by seeing, right? If we see any input image or if we see any animal or any fruit or anything, we can easily identify it. We will remember it, correct? We anyway can easily remember it because in our brain we do have millions of neurons that will help us to remember an object what exactly we are seeing. We can easily identify the features, correct? The same thing computer has to do. So sometimes the features cannot be extracted manually. We need a system that can automatically do the feature in extraction and also has to do the classification. Classification anyway we know there are different algorithms are there to classify an input image is either car or not. That is for sure it's there. But how do we do feature extraction? Feature extraction has to be done manually earlier in machine learning, but now by using deep learning, it can automatically extract the features. Features means simple, identifiable parameters in an input image. For example, how do you identify this image is a car? Because it has wheels, it has a structure. So all such things are features. These features is really difficult to extract numerical values, right? We need a system that can do automate this. That is what automatic feature extraction. That process has to be done in deep learning. Okay, the deep learning involves that automatic feature extraction and classification. Automatically, it going to predict us whether this input image is not a car or a car. Okay, this is the basic difference between machine learning and deep learning. Is that clear? Hmm? Ranjit?
Yes, yes, Ashwin.
Yeah. And let me show you a basic difference in terms of lines. Here, for example, in machine learning, so it is a statistical learning methods. All are statistical method. But if you can see any machine learning algorithm, all involves pure mathematical equations and mathematical knowledge. Statistical based learning methods are there. But what is the inspiration to the deep learning is it mimics the human brain. It mimics the human brain. I already mentioned you guys in the first lecture. If you really wanted to learn data science or artificial intelligence, um, always you should observe how exactly human is working. Right. For example, if you can see any image in front of you, so you can easily remember its features and you can easily identify it in reality, right? This same type of knowledge, how can we feed to the machine? Here is the question. Then we can easily say that we do have neurons in our brain that will actually help us to memorize the thing and then will forward the information wherever it's required. But when it comes to the machine, how do we make this possible? So I will show you a pictorial representation. How does actually it possible using mathematics a little later. But before that, we should understand that it mimics the human brain. Deep learning feature. When it comes to the features, machine learning do require feature engineering that has to be done manually, but in deep learning automatically learns the features from raw data. Okay, so these are the basic definitions aspects and key differences are obviously requires manual extraction of features. Here automatically do that. Example, for spam detection an ML algorithm need need features like number of suspicious words. I already mentioned this in my NLP lecture, right? So we have to do a lot of features building IDF vector, TF-IDF vector, and number of punctuation marks in the mail, also number of links in the mail, and capital letters in the uppercase letters in the mail. All such things are features. We have to extract them manually in terms of machine learning. But when it comes to the deep learning, it doesn't require anything, just inputs we have to feed. Just allow me a second. Someone is trying to join. Yeah. uh, Good. um, what I mean to say is, in deep learning, so we need not to focus on features. Deep learning can automatically learn features itself. How does it possible? How does deep learning work mathematically? I will explain you little later. Just first, let us focus on the theoretical part, the difference between the machine learning and deep learning. Data requirements. When it comes to the data requirements, what is the difference between ML and DL? Small to medium data sets, if you're dealing, then machine learning is the best. But if you have a larger data sets, millions of samples for training, then deep learning we can go for. For example, logistic regression can work with 1,000 samples. And ResNet, anyway, we do have a discussion. I mean, we do can have a discussion on this. This is all comes under transfer learning. After maybe Wednesday, yeah, maybe Wednesday I will cover this topic. Most probably Wednesday I will cover the transfer learning approach, which is really easy. um, this is what evaluation of fine tuning, what we are seeing it in even LLMs also. ResNet, ImageNet, okay, all those are from Facebook and Microsoft models. These are all, and Google ImageNet actually. Those are all already trained on a lot of images. You can see the number, nearly 1 million images they can do. And then performance. When it comes to the performance difference, s- uh, ML always use simpler models like decision trees, SVM. And here we have transformers, CNNs, RNNs. Those are all complex models in deep learning comes. Yes, machine learning models are interpretable. We can explain predictions, but deep learning acts as a black box, hard to interpret. I will also show you what exactly black box means in deep learning neural network. Machine learning, when to go for? It is very good for structured data. Remember this. Either tables, CSVs, if you're dealing with, then better you can go for machine learning. If you are going with unstructured data, I just mentioned a few minutes back. If you're dealing unstructured data, for example, images, audio, text, then deep learning is best option. Computational power. When it comes to the computational power, it is good if in machine learning, which we can run it on CPUs itself. That means if you have a computer having a CPU, obviously you can easily run machine learning models on your machine. But if you are dealing with the deep learning, then sometimes you require GPUs or TPUs. That's the main reason why I'm from the beginning I'm considering this Google Colab, because Google Colab can provide you a default free GPU and TPU. Okay, but these two things we are going to use in upcoming sessions, not now. Um, okay, okay. I also provided the use cases when to go for machine learning and when to go for deep learning. Please do refer. Let me give you a simple example. In machine learning, if you're dealing, then small or medium data sets are available. If you have a structured data, if interpretability is important, that means the output prediction that you want to explain it, then interpretability is important. Then machine learning, then limited computational resources. This is really important to note down. If you have a limited really computations, then CPU, something like that, then go for machine learning. Examples also, we anyway tried spam detection, we tried it in credit scoring, sales forecasting. All such things are examples of machine learning. Deep learning, when to go for deep learning, is preferred when you have a large data sets, and especially the data sets are unstructured in form like images, audios, and text. Deep learning is the best one, and high accuracy is critical. If you are expecting a high accuracy on unstructured data, then the solution is a deep learning approach, like self-driving cars. All such are deep learning based. Feature engineering is difficult. Whenever you feel feature engineering is really difficult, then deep learning is preferred. Examples here you can see image recognition. Tomorrow I'm going to cover that, and speech to text RNN. Maybe Thursday or Friday we are going to have this discussion RNN, and autonomous driving, deep reinforcement learning. These are the examples, solid examples of deep learning. And visualization, if you really wanted to see the pipeline, anyway, this same pipeline we've been discussing from the long time. Like for example, in machine learning, raw data has to go with the feature engineering steps. After that, that has to forward to the training model. Either it can be SVM, random forest, or any one of the models, and then we can expect the predictions, right? But when it comes to the deep learning, so raw data will be there. The pre-processing has to be done, and but deep neural networks we have to assign, and that will help us to get the predictions. Here it requires a manual feature extraction. If you remember our machine learning course, okay, first what we have performed, you just revise. First, data set was given to us. Then we have done EDA, right? We have done EDA where we literally calculated the graphs and also I mean we literally plotted the graphs and calculated the mean value, median value, all such things, impute the null values, outliers detection of and also we converted the categorical values into numerical values, feature engineering, everything we have performed, right? We only have performed. Finally we also selected what are the input features, what is an output feature, everything is manual there. But when it comes to deep learning, just you need to have a raw data and little bit of pre-processing according to the domain. Then a deep neural network is important to build. After that, that will help to get the predictions. So automatic feature extraction and automatic feature learning is what a main capability of deep learning. So simple summary, feature engineering here is manual. I've been saying it from the long time. And automatic feature engineering is there. Data needs large. Here, sometimes we do require deep learning, require GPU, TPU. Interpretability is very low. It is a black box. That means explainability is very less. Training time, actually, it is very slow, and it is very best for, very good for uh, unstructured data. If you have unstructured data with you, then deep learning is very good to go. I hope it is a really quick introduction uh, with respect to deep learning and also differences we have seen between machine learning and deep learning, right? So now we can have a formal discussion about first concept in deep learning, that is artificial neural networks. Okay, so this concept is actually huge. Okay, the deep learning concept is actually huge. It's not like machine learning. We can easily learn one algorithm one day. The concepts are really a lot many, but don't worry. I'm going to give you the clear introduction of every topic. So these concepts actually do require a lot of self-study because it will take a lot of time to really research. If you are a research minded person, then definitely it will take solid time. Or else, if you are targeting as a developer, then you just need to learn the basics. That means you can cover my lectures, upcoming lectures, and this lecture. That will be enough if you really wanted to focus towards programming and implementation in software. But if you are an enthusiastic a person and a mathematician interested person, and if you really wanted to know that how it becomes so easy in deep learning to get the best accuracy, or as if you are interested to learn how come my computer can easily learn the features automatically, how can it possible with the help of mathematics. So if you really wanted to know that, then you need to do a lot of research because a lot of materials are available in the internet, and there are solid amount of textbooks. Okay, you can refer them, but we are not going to cover the in-depth mathematical institutions here because time is really limited to us. So what I'm going to cover is what exactly the topic is, how can it implemented in Python, and how do we solve projects, real-time projects. These concepts that we are going to cover as a part of deep learning. In machine learning, we have covered the good mathematical stuff because those are really important to understand. That is why I mentioned many times machine learning is really important, where you can spend a lot of time in learning the algorithms and you know, the different ways to construct a machine learning algorithm with different hyperparameters and all. Here in deep learning also do have a lot of hyperparameters. Anyway, one by one we will get discussed. Don't worry. And this concept also, before getting into the neural network, um, you need to always focus, because if you get miss or if you get diverted, maybe again it will take you time to revise it. That's why I need your attention. um, yeah. So this have you anyway, two people are there in this session. So I encourage if you can answer my questions, or else if you can interact with me. Okay. Yeah. So have you ever seen this image before? Anybody?
Yes, yes, Yashwant.
Okay. Okay. Where exactly? What exactly it is? Anyway, it is
When
there.
we are in the this neurons, right? We have the
Yeah.
cells, and in our 10th class,
Exactly.
yeah,
Exactly. So anyway, this concept is known to you. I mean, this particular name is known to you. Observe this. This is actually one of the neurons what we have, but in general we will be having around so close to 10 millions, maybe more than that. I'm not very sure how many neurons are there in human brain, but it is a really typical subject. Even in medicine also. Even in medicine also, if you have any medicine students as friends or medicine people, you can go and ask what is a typical subject in the entire medical related things or doctor related studies. So most of the people say that neurology is really one of the toughest subjects there. And why? Because it is, even now humans did not understand the complete structure of brain. They are still researching. So there are a lot of unanswered questions are there with respect to brain and all. But we are not going to focus more into that. What happened? Let me tell you a brief history. So deep learning was there in 1950s. Deep learning was there. Even machine learning also was there. Even 1936. AI was even there. 1947, 1940s. But why AI is not popular till date? Because at those days, people don't know how to manage data. Right now we have cloud system. There was no cloud earlier, and computation is really important. Computation, so they don't know how to compute with less with more efficiency and less time. But now we do have CPU. After that GPU. After that TPU. Now even quantum computers are also on the way, right? So recently, have you seen the Microsoft released quantum computer chip? That means computation has gradually increased. Okay. So eventually the applications with respect to the deep learning also getting increased. And in deep learning concept, especially mathematicians plus before mathematicians, the physicians or the biology scientists, okay, or neuroscientists, I can say particularly. Neuroscientist has it out. Computer scientists, computer scientists obviously will have it out. How come human is capturing the things? How come human can remember a thing for a long time? How can human is identifying the thing? For example, uh, um, when we are at 10, 10 years old, we can learn, and we had learned a lot of things, right, with respect to animals, birds, right? Many things we learned. Those things still we remember now, right? We can easily identify. If you can suddenly see a peacock in front of you, you can easily identify it is a peacock because you already knew how exactly peacock looks. How come it's possible? Then there they approached to the biologist, to biology scientists. They said neuron is the one which is really helping human, to transfer the information from one place to another place. to the brain, and then forward the information from brain to again to the respected organ. Okay, then mathematicians, they approached mathematicians because computer science require mathematics. Correct. So mathematician people, what they did, they have formed a formulation to this. They have formed a mathematical formulation to this neuron, and that mathematics has been transferred to the computer scientist students or computer scientists, and they that scientists are literally, coded to feed that information to the machine and started training to the machine to learn from the data. Okay, so here, if you can see this picture closely, there are four important parts are there. First one is called synapse, second one is called axon, third one is cell nuclei, fourth one is dendrite. Synapse, dendrite, simply like, input to output, output to input. Axon is a transforming structure, you can see, and cell nucleus kind of a memory. So this is what exactly biological neuron. Same thing mathematicians defined another neuron network which also has the main four parts or main three parts. Those are, see, these are input, this is inputs, these are all inputs or input neurons. Okay, and this is what in major, I mean, hidden layer, they're also called as activation function, and this is an output layer. Okay, and deep neural networks, if you see, the deep neural networks basically having, this particular artificial neural network is simulates like this. The major biological neuron having three inputs and output, and in bit a processing unit, right? Similar to that biological neuron, this artificial neuron also having three parts: inputs, the activation function, and then output. Okay, so in this way, the mathematicians derived a structure to the biological neuron, and then forwarded by, you already knew that there is not one neuron which is there in human brain, right? There are many neurons. We also know that how that actually connected in brain, one to one connected. Similarly, here also you can see one input layer is there, and let me use one more color. Hidden layers are there. These are all hidden layers, and this is an output layer. This is input layer. This is called hidden layer. I will explain you one by one. Don't worry. Okay, I know it is kind of complexity, but it has its own complexity. But still, it is understandable concept only. It requires patience and uh, continuous attention. That's it. Here you can see this is called black box. So inputs are okay, output is okay, but what exactly happening in between is what black box. We don't know what exactly happening. Inputs, we know that. Anyway, every problem statement will have an input. Every problem statement do have an output. What exactly we wanted to predict. But what actually in between happening is what a black box. That's what. Here it is very clearly mentioned in the different in between the difference between machine learning and deep learning. Here you can see interpretable machine learning models are interpretable, that means explainable. We can easily identify, right? You also could have understand in machine learning model, every machine learning model I explained the mathematics, clear mathematics, clear is there, interpretable is there. But here it acts like a black box, it is very hard to interpret. So what exactly black box means here? The the middle hidden layers do work as a black box. But anyway, I will try to explain you how exactly the mathematics works behind. But before that, let us see. For example, this is an input image. So let me use another dark. No, maybe this. Okay, this is an input image. She is Sarah. Okay, so we want our machines to predict her face or to detect her face. Okay, next time if she comes in front of the computer has to predict whether the image which is there in front of the computer is Sara or not. How does it possible? We know that input image, this is an input. Let us consider it is having 28 cross 28, 28 height, 28 width, and three dimensional. Means red, blue, green. We know that, right? RGB, red, green, blue. Okay. So 28 cross 28 cross 3. So those many input values, these are all input neurons. Okay. In between we do have, in between we do have hidden layers. These are all hidden layers. And this is an output image which will help us to detect whether a person is Sara or not. Okay. And here, if you can see, these are the features. See the edges, the nose edge, the eye edge. Okay. The mouth part, the ears part, the forehead. Okay. So eyes, ears, eyebrows, all such things are here plotted. From there, it learned the features, and that features will help machine to predict or to detect. So now let us break down one by one so that this concept is really understandable. So I'm considering to explain this concept. I'm considering MIT uh, reference material. So it is really easy to understand the concept. Anyway, I will forward this material to you. Whenever you get some free time, you can learn from there. Okay. So here you can see low level features, mid level features, and high level features. I already mentioned you one thing, right? In machine learning, the feature has to be given by humans or data scientists. But when it comes to the deep learning, what is happening is these features, these features are going to learn by machine. You can see these are all features of the face, human face. These are all things going to extracted by deep learning hidden layers. Okay, hidden layers. Got it? And mid-level features are, you can see, much more easier to identify. The eyes part, nose part, just I mentioned before. And these are high level features. These are low level features are something like edges. High level features are the body individual parts or face individual parts. And high level features are something like the outline of the face. So these all feature extraction they happened in deep learning automatically. We need not to specify. Okay, so what are noses, what are eyes, what are ears? Deep learning automatically learn that. But how does it learn? How does it learn? It learn with help of artificial neural network. This is what ANN. We debug it, how exactly it works. It will have, as I mentioned, input layer. This is what input layer, where we have to pass inputs as neurons. This individual cell is there, right? X1, X2, X3, X4, upswan, Xn. These are called as neurons. Remember this. These are called as neurons, neuron cells. What are the values which are there in neuron? It can be around 0 to 1. We can give any value in between 0 to 1. Let us consider as a neuron. Okay, what are these? These are called weights. These are called weights. These are random. Random numbers can be assigned. Okay, we need one function. We need one function to correctly map. We already know that y is equal to mx plus c. Okay, linear function. Okay, so we already know this linear function, correct? So same way, where we also already discussed, m means slopes and x means input features, inputs, and c is y-intercept. Same structure here we are also going to draw, where here you can see, how can I define? Yeah, w transpose x, okay, plus b, okay, is equal to y. W transpose means weight. These are all weights. And x values can be 1, 2, 3, any value, or else in between 0 and 1. Okay, weights can be 22, 23, 24. These are random values. Okay, don't worry. These are random values, and these are our input values. If you multiply these values, you will get one vector, right? And that vector has to be added one more parameter that is called bias. This is also randomized value, which is has to be given. Okay, so then we will get that value. Okay, so now let us try to understand this concept with the help of an example. And one more thing, this input, this input, uh, I mean, this input's going to come up to this summation, and then we have to pass it to the activation function. This is called activation function, and there are many activation functions we can use. For example, sigmoid. That sigmoid will help us to convert the linear to the non-linear. Non-linear. That non-linearity will help us to predict the output. Of course, you might be confused. Don't worry. Uh, Let me explain you with an easy thing. Here you can see. Just focus on the thing. Let us consider. Let us consider. Observe this image, and then observe my drawing. Let us consider an input image which is having 28 cross 28 length. Okay. Then how many input neurons are required if I wanted to pass this image information to my the neural network? For example, this is an input image of handwritten word 7. Got it? So you know that image is combination of pixels. Correct? Image is a combination of pixels. This image can be represented like this: 28 cross, these are 28 rows and 28 columns. 28 cross 28, and every value is a pixel value. Where exactly 7 is there, for example, this is 7. Remaining all values are empty. You can see those I can fill, those values I can fill zeros. Where exactly 7 is there, I can fill a value, a suitable value. Let us say pixel values, you know, right? 0 to 255, the values are 0 represent maybe black, yeah, black, and 1 represent white, and remaining 0 to 255, right? The all values are between. Here let us consider this are value, this is 7. Where exactly 7 is there, instead of 0 we may have 1 1 1 1 1. Got it? Remaining all values are zeros. This is the representation of digital representation of this image. Understood up to now? Is that clear? Is this clear up to now? Can I get a quick confirmation?
Yes, Ishwant.
Very good. Now understood. Sorry, now understand. So 28 size, size is having 28 to 28. I am considering it is not a three-dimensional image because it is not a color image. Let us consider this is a grayscale image. So grayscale image means it is in two-dimensional only, and in that two-dimensional it is having 28 length, 28 width. Okay, so total 28 times of 28, how much it will be? 28 times of 28 means I already calculated, it is 784. So total 784 input neurons are required. If I wanted to pass this information to the neural network, then 784 neurons are required. Input neurons, all 784. Got it? And the values, what are the values then? So these values only 0, 0, simple. This will stay 0, 0, 0, 1, 2, 3, something like that. Because the values are in range of 0 to 255. I wanted to normalize all these values. So what will I do is I will divide every value by 255 so that I can normalize everything under between 0 and 1. And also I can maintain that I can maintain that thing. In that case only 255 by 255 which actually gives us 1. That is what represented by white. Got it? In that way I meant 1 represent white, 0 represent black. The values are always between 0 and 1. Okay, So in that case, every value will get divided by 255 so that all 784 neurons will get occupied with its respective pixel value in between 0 and 1. Got it? So input neurons are fixed. Then what is the next step? Random weights. How many input neurons are there? Those many random weights has to be given. How does these random weights are working? Let us discuss the topic later. But assume that random weights are given. Okay. And how does it works means, let me take a new slide and explain this concept. See, there are 1, 2, 3, 4 like that. 784 neurons are there. Next step is these are weights are also there. Next step is hidden layers. This is input layer. This is you. I hope you understand. 784 is what input size. That is why 784. Let us consider I'm having, let us say, uh, you know, an image 28 of 28. So 28 into 28, 784 is what is an out. That is then the second thing is called hidden layers. This is a part of hidden layer. Hidden layer. Hidden layer. Hidden layers means it can be generally it can be either one hidden layer or two hidden layers and three hidden layers. And how do we decide the number of hidden layers which has to be there in deep learning means there is no rule. Generally, what all data scientists prefer is to try with one hidden layer and check the accuracy and all the performance of the model. If it is not good, then add another hidden layer. And one more thing is how many neurons that we can fix in hidden layer. That is another question, right? That is also not fixed. That is also an optimal parameter. That is also a hyperparameter where you can choose one number randomly and try building a model. If you're getting optimal results, fine. If you're not, means change the hidden layer neurons and increase them or decrease them. That it has to be again a lot of computation we have to perform. Let us consider 784 input neurons are there, so we can consider, let example purpose, 16 neurons in hidden layer. So 786 are there, right? 784. So just for an example purpose, just for explanation purpose, let me consider 5 input neurons only there. The same strategy even work. The number is 784 also. Let us consider here 5 input neurons are there. Hidden layers, uh, 3. Let me consider 3. Okay. Observe. Okay. So how does it actually it means each input neuron has to connect the hidden layer neuron. You can see, you understand that, right? This is W1, W2, W3. Again, one more thing, W1, wait, 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 W1, W2, W3. This follows the same. This also follows the same. And even this follows the same. Okay. So the equation to get to here means, what is the equation is, we need X. X means the input layers, input neurons, and we need a W matrix. Okay, it has to multiply a dot product, and then one more parameter is there that is called bias. Three neurons means three bias values will be given. Bias. Okay, bias also has to given. These are all arbitrary. These are experimental. Okay, and why do we require bias means it is just for inactive, how high the weighted sum to be. That is what I will explain that. Okay, once you reach here, what is an equation will be is bias. Okay, so the equation will be like this. You can say, let me write it here. Um, let me consider instead of X, I will say it as A. Okay. A1, W1 or X1, W1, anything, yeah, as you wish. W2, A2, W3, A3 plus W4, A4, something like that, WN, AN. Okay, WN, AN or AN, WN, both are same. This is what the equation. Okay, so if we add a bias, okay, so W1, A1 plus W2, A2 plus W3, A3, one bias only. Okay, then let us consider minus 10 is bias. This bias actually will help us, how large the weight to be, and to control the weight parameter, how high the weighted sum to be. Okay, and after that there is one more thing we have to implement, sig. This is activation function. Why do we require activation function? So here actually we need to pass all these parameters to an activation function. If you remember, logistic regression, the formula is 1 by 1 plus e power minus z, right? This is an equation of sigmoid. That time I already mentioned sigmoid. What will it do is it will simply convert the values into continuous values into 0 to 1. If any value above 0.5, then we can consider class 1. Below 0.5, consider class 0. Here also, we need to pass all those things to one's activation function. Let us say sigmoid is also one of the activation functions, so that it will convert all such values to the non-linear values. Okay, if we decide another one more hidden layer we require, means we can simply pass the information to the similar way. Okay, and finally we have to have an output layer. An output layer, nothing but how many values that you want to predict. For example, if you have two classes, then two output neurons you need to mention. If you have 10 classes, then 10 output neurons has to be there. This is called output neurons. So understand this concept now. Simply, in artificial neural network, we will be having input layer, hidden layer, and output layer. Input layer is also is anyway you understood, right? So it is simply how many inputs are required. That is what input layer. And output layer is also very easy to understand, how many classes that we have in our application or in our problem statement. That many neurons we need to fix in output layer. But what is the journey in between to reach to output layer? To reach to output layer, what is the journey? This is what actually a black box. In this black box, what is happening means, so weights are playing a crucial roles, and the activation functions are also plays a crucial roles. That will help to understand the feature is really having how much weightage. Okay, and automatic feature extraction is how this is how exactly it is working. Okay, let me show you again this MIT lecture. Now it is really easy to understand for you. For example, these are all input layers. Okay, these are all input layers, and this is what the bias, what I just mentioned, and along with the weighted parameter, weighted vector. Okay, weights vector, this is has to be perform this summation. The summation is simply this one, w naught plus w naught means here it is saying that bias. Okay, don't confuse, it is a bias. And w, capital W means w1 w2 something like that. And why do we require X transpose? Because if you want mathematical matrix multiplication, you need to maintain the matrices lengths, right? Matrices. So that is why we have to transpose the X and then keep the Y, keep the W matrix as it is, so that if we can do the dot product of these two and then we add the bias, that is what exactly the summation do. And after that, what is this G? What is this G? G stands for one of the activation functions. Let us consider the sigmoid is an activation function. If we pass these values, continuous values to here, it will generate, I mean, it will produce, I can say, the values between 0 and 1 with a threshold of 0.5. Any value above 0.5 classes as 1, any value below 0.5 classes as 0, classifies as 0. In that way we can get the classification has to be done. Got it? So let us consider there is only one class to classify. Here, let us consider there is only one class to classify whether a person is good or not. Good or not. There is only one output, either good or not. Okay, so what are the input parameters? Input parameters can be, study percentage, character percentage, and what we can say, let us consider um, discipline. We need to fix the proper weights. Which parameter actually has more weightage? These weights are really important in that perspective. For example, if we want to decide a person is really good or not, with respect to character, then discipline is what very important, right? Discipline is what character percentage or any other sensitivity or else kindness, all such parameters are really important, but discipline holds a largest weight. So we need to fix those weights so that we will get to know what features are really important to decide. Then we can go with this summation. This is what exactly it do. But what will it give? It will give the linear value, right? Linear value, continuous value it will give. But how can we decide it is a good or not? Good or not means it is always a probability, right? It is always a probability if you observe. Probability, isn't it? I already asked the same question in machine learning classes also. It is a kind of a probability. It will saying how much, right? Percentage, right? How can we convert then this non-linear value to the, sorry, linear value to the non-linear value? With the help of activation function. Got it? Is that clear? Now is that clear? How exactly one perceptron work? This is the concept of perceptron. Perceptron means there is only input layers and summation, and then with activation function, this is one simple layer. This is what perceptron. Is it clear now? This concept is clear? Can I get a quick confirmation? Huh?
Can you go again?
Yeah. I mean, how exactly the model, the deep learning perceptron can predict whether a person is good or not, right? So we have to concentrate on the inputs, weights, and the the linear property. After that, activation function really helps us to convert that linear property to the non-linear, means in between zeros and ones, and means probabilities. And in that way, we can predict a person is good or not with the help of a deep learning concept perceptron. Okay, this is the concept of perceptron. It requires input layers and then no hidden layer, only one hidden layer, and then the activation function followed by the predictor value. Okay, these are really important things: inputs, weights, summation, non-linearity. We have to convert the non-linearity, then we will get the output. Okay, and I mentioned, right, there are many activation functions are there here. This is what an activation function. There are many activation functions are there. Common activation functions are, you need to understand the sigmoid. Sigmoid we anyway discussed in logistic regression as well. And hyperbolic tangent, this is another. This is the formulation. Z is simply that Z is always similar in every application. That is, Z is equal to double the X transpose W plus W naught or B naught. This is bias. This is weighted matrix. This is input features. This is what Z. If you if you replace where exactly Z is, then e power Z minus e power minus Z divided by e power Z plus e power minus Z. You could have seen this in hyperbola functions in class 12, right? So why do we require hyperbola? Means that is also one of the property where we can convert the linear to the non-linearity. So here you can see with the g dash of x, z and z of z, the pictures. So we are going to convert that to non-linear property. Okay. And another one is really, really important. This is quite common in deep learning activation functions. That is ReLU in short, rectified linear unit. This is simple to understand. This is in between maximum of 0 and z. If there is any negative value which we come out of this particular function, okay, that we will consider as 0. If there is any value which is greater than that is considered as 1. You can see in between 1 and 0 if z is greater than 0, otherwise 0. Sorry, z is greater than 0, then we can say it as 1. Otherwise, it is 0 always. Now, that means less than value or negative values. Okay, this is the concept of activation function. And here you can see why it is important to introduce the non-linearity. You may have a question, correct? So why does activation function, very important question, why activation functions are required? Why activation functions are required means, for example, if you observe this picture, let me take a different color. Yeah, if you observe this picture, if you go and draw one line to separate the green points and the red points, we cannot draw like this, right? We cannot draw like this because still below this line the green points are there, still the above this line the red points also there. We cannot separate the values by using linearity. This is a linear line, correct? You can understand here. So here is a linear line. Linearity, using linearity we cannot classify them if the data set is a club of like this. Then how can we classify them? With the help of non-linearity. This extra box you can see covering all the green lines, green points. This is what non-linearity. We need to introduce the non-linearity so that we can easily classify them accurately. Okay. So here you can see, let us consider the weights are 1, 3 and -2. Okay, simple explanation is given here. X transpose means x1, x2, W means 1. There are, see, bias means 1, sorry. Weights are only 3 and 2, and bias matrix is 1. Okay, so if you can multiply these two things, this is 2 rows and 1 column, and this is 1 row and 2 columns, the multiplication matrix will have 2 cross 2. Right? So, and here you can see the formulation is 1 plus 3x1 minus 2x2. This is a linear line. Then we need to introduce this non-linearity property, that is what activation function, so that instead of having a straight line, a linear line, we will get this non-linear property. Okay. So here you can see this is a linear line. Just now we discussed here. This is a linear line. And this linear line actually will define as, you know, if there is any point, for example, -1 comma 2, this is what x. If I consider x1 and x2 are -1 and 2, if you compute the values are bit, let us say 0.0, 0.002. Okay, and here if I convert this to like this, if any value less than 0 are, you know, if any value less than 0 and the y value is less than c, all belongs to this category. Or else, if z is greater than 0 and y is greater than 0.5, all belongs to this category. How do I get this? Only because I'm passing this particular value into a activation function. Let us say activation function is 1 by 1 plus e power minus z. If you are interested in mathematics, just substitute this value here. Here z is equal to simply 1 plus 3x1 minus 2x2. Okay, here x1 is -1, x2 is 2. That is what considered point. Then the equation is 1 plus 3 into -1 plus 2 into 2. Okay, 1 minus 3 plus 4. That means -2 plus 4 will give me 2. So I need to pass this 2 in an equation called 1 plus e power minus 2. Why this formula came? This is one of the activation functions, that is sigmoid. Just now we discussed. Don't confuse. Here we do have many activation functions, but these are the most probable using one, sigmoid. This is what the formula. If I wanted to convert this linear line to non-linear like this, I need to apply any one of the activation function. Here, for example purpose, I am using sigmoid. If you can do this mathematical stuff, 1 by 1 plus e power minus 2, you will get so close value as 0.002. So there we can fix one criteria. That criteria is here, you can see. If any value that z means, you know, right, 1 plus 3x1 plus, if you substitute, the z value is here 2. If any value is less than 0 and also y is less than 0.5, okay, then those points are belongs to this class, otherwise belongs to this class. This is one way to decide, okay, which class it belongs to. Okay, here you can see the same thing being given here in different ways. Okay, and in coding also given. Anyway, we will explain that coding separately, don't worry. But I hope you guys understand. Here you can see the hidden layers. Hidden layers, I just mentioned that the number of neurons were not fixed. This is arbitrary. Arbitrary means anything can be considered random. But this is a hyperparameter. Later on you will understand, okay, the accuracy is very less, then we will increase or we will decrease the hidden layers or hidden layer neurons. Okay, so this is a simple layer neural network. This is a simple layer neural network. These are the weights, and these are the weight with respect to the first neuron. That is what it is discussed as W power 1, and first one with respect to the second, and again W power 1. Okay, and 2 comma 2 second one, and something like that, Wm comma 2. Here it is also given W power 1. This is W power 2. These are all W power 1 because that is first layer. Talking about the first layer, that is what all powers are W1. Okay, and below here you can see, below here, so below value will actually talk about the first layer. This is the first neuron it is coming from. That is why W1, and it is going to the 2, and the second neuron it is coming and it is going to the second. Third neuron it is going to come and it is going to the second. I hope you understand this. The weights. Okay, the distribution of weights. Okay, let us consider we are having x1 input neuron, x2 input neuron. We are having only 3 hidden layers. Okay, then how do we define the weight vectors? If you are interested in mathematics, then it is really easy to understand. Weight, these are all first two, means first layer values. This particular value. Let me take one more color. This particular value is from first neuron and it went to the first neuron of the hidden layer. And this particular value come from first neuron and goes to the first neuron. So, sorry, come from the first neuron and goes to the second neuron, and come from the first neuron and goes to the third neuron. And this is the one, it is second neuron 1 and going to the first one, second neuron 1 going to the second neuron, second neuron 1 going to the third neuron. Got it? These are the weights in the first stage. Later on, if we have one more hidden layer, then the process continues. Okay, here you can see this is g of z1. G of z1 means, don't forget, g means activation function. Z1 means, you know that, X transpose W plus B naught means bias. Okay, this is what Z1. If we pass this one in G, that is what activation function. You can see how many input, how many hidden neurons are there. Those many activation functions will has to happen. Okay, and then that values will be given to the y. Then that will help to get the y value, predicted y value. Okay, here you can see input layers, and here weight matrix has to be done, and the hidden neurons, and then some operation has to be done, and then output layer. Okay, and mathematically these are the formulas just now we discussed. And yeah, if we really wanted to classify them, and already we discussed, so these are input layers and then predicted. So yeah, and second concept, next concept is, so far what we discussed, input layers we discussed, weights we discussed, activation function we discussed, and output, how exactly output is getting, also we discussed, correct? Now it is important to know whether this output is actually true or not. There is a question, right? It is a true or not. It can be true. It can be the correct value or not. For example, let us consider there is only one value. Output is only one. One neuron is enough. If that is yes or no. Yes or no. There is only one neuron is enough to decide whether it is yes or no. Correct? Okay. If I get yes means one, no means zero. If I get one here, that means yes. If I had zero means that is no. Okay. So try to understand now and respond me. Okay, let us do this. Okay. We have 4 comma 5 as input. Okay, 4 comma 5 as input. Let us consider 3 hidden layers are required. Calculate. Weight parameters are there, right? Anyway, weight 1, weight 2, weight 3, and weight 1, weight 2, weight 3 with respect to those things. I will only calculate one thing to make you understand. Okay. So 4 comma 5 is what X transpose. Weight matrices are like, let us say 3 weights are being used because 3 hidden layers are there. Okay, 1, 2, 3. So 3 weights I'm using here. Let us say 10, 12, 12 random weights. These are okay. So what will I get? Okay, here 2 rows, sorry, 1 row, 2 columns. Here, uh, here let's say 3 rows and yeah, any doubt? Okay. Here, W1, it is from W1 going to the 1 comma 1, 1 comma 2, 1 comma 3. Okay. So again, simply this is also W2 comma 1, W22, W33. Okay. And it should be having one more like 12, 13, 14. In that case, it is 3 rows and 2 columns. It should be having one row. No, it should be having a matrix. Has to be one, has to be maybe this is 2 rows and 1 column. And here, if I get transpose this thing, um, 2 comma 3 maybe. Okay, then I can get 2 comma this just a second, one. So that matrix has to be map, and then these two will get multiplied, the dot product. Okay, we have to do that adjustment with respect to the weight matrix. Then we will get the values, and that values we will pass it to the activation function g of, and we will get some values like 0.22, something like that. We come to know that if any value less than 0.5, that classifies as 0. If that value comes to, for example, this neuron got activated and then forward to do this, 0. Okay. Then if 0 is there, that means no. Got it? So in that way we will predict. But how will we decide whether our predicted value is correct or not? We have to go loss. We have to understand the loss function. Okay. There are different losses are there, loss functions are there. For example, empirical loss is there. Okay. This empirical loss measures the total loss over our entire data set. Total loss. That's why the function. This is what empirical loss formula, empirical risk or cost function, objective function also can be called as. This is calculated on the total loss. Second one is called binary cross entropy loss. It will always in between the probabilities of between 0 and 1. Okay. And mean square error loss. This can be used with regression models that output continuous real numbers. Then we can use mean square error loss. Something like that. Those loss values will really help us to detect or to find out whether a value, you know, like whether a value is a real one or not. We anyway discussed this loss in regression concepts, right? There we already mentioned about if the loss is less, that means, you know, if the loss is less, then the model performed well. So we always have to focus on minimum loss. That is what, loss optimization. We always have to follow the minimum loss, the the lowest loss. That is what we always target about. Okay. So the lowest one is what always target about. Okay. So this is how the points one by one gradient descent means. First, for example, it will be there. Then one step. So the step means jump from one place to another place. That is what called as learning rate or eta. Eta can be step size. Okay. Like that we will go one by one. So wherever we get the less loss, that is what we fixed it. So what if our how do we every time, for example, let us say, try to understand this one. This is another important concept. For example, here we are. You identified that loss is high. You identified that loss is high. Then what step has to be performed? So for example, the real value is 30. Okay. The real value is 30, but we got as 90. So there is lot of loss, nearly 60 points loss. Correct? So how do we get the most optimal value next time? Means simply you have to go back. This is what back propagation. Back propagation. So simply we have to go back and update the weights. If weights are, I already mentioned these weights are really important to decide or to predict the output class. So that is why we have to update the weights and come back to again the predicted value and check the loss. If the still loss is high, then again go back and update the weights and again come back. I already mentioned these weights are random values. Update these values and again come back till you get the most optimal or so close value of loss. Got it? This is what the loss optimization. But what is the technique that we are doing this updation of the weights? That is what the technique of. That is what the technique of. Here it is grade. That is what technique of. In gradient descent, that is what we do. Optimum. We will get the. In gradient descent is what the concept. The concept will help you to get the less loss in terms of updating the proper weights. This eta is what I just mentioned. This is what the step size from this place to this place, how much depth we need to go. Okay. So gradient, this is the algorithm that it will work. Stochastic gradient descent. This is what stochastic gradient descent, and the difference between is simple. Here we use random noise. Okay, and then compute the gradient and then update the gradient, and ultimately we return that. So this particular thing is really important. Compute the gradient. Okay. And this computing the gradient in the back propagation, there are also techniques, the weights. How you may have a question, right? How exactly the weights are being given, and that particular concept we will have different ways to assign weights. That is one of there are different algorithms are there. So those algorithms are like this: adaptive learning rates. Okay, you can have gradient descent algorithm. If you use gradient descent algorithm, I just shown you right one graph, and where you get the lowest error. That is the strategy of updating the weights. One such algorithm is optimization is gradient descent. Another optimization is there are a lot of gradient descent, and also there are stochastic gradient descent, and there is next one is mini batch. Okay, all such things are comes under updating the weights. And regularization, you if you remember, I already mentioned discussed this L1 regularization and L2 regularization to overcome the problem of overfitting and underfitting. If you realize that there is an overfitting or underfitting in terms of deep learning, then we also can do the regularization. Here the regularization will be dropout. What is this dropout? We literally going to drop some neurons in the hidden layer, because these hidden layer neurons I just mentioned, right? So these are random. We can mention any arbitrary number in bit as a hidden layers, and then we do test it. If we identify there is any regularization one, then we will go with the concept of dropout. Simply we randomly set some activations as zero. Okay, some activations as zero, dropout. Randomly set some activations to zero, typically 50%. Let us say 50%. If we fix, then dropout is 0.5, means 50% of the activation layers will get dropout. You can see, got it? And this is how dropout works. Then the second optimization means the second regularization is early stopping. Early stopping means we will observe the loss, training loss and testing loss, both the things we will observe wherever the two are mapped. Here you can see these this place both are so close, but after that it went away, down. So we will stop it here. That is what early stopping. Here you can see we will stop it here. Okay, this is the concept of early stopping. Okay, so now let us club everything. Now let us club everything. So even if you missed any topic in between, it will help you to understand clearly here. So now we reached at the end. So see, just simple understand now. Okay, now you have to respond me whether you get this concept or not. Okay, so let us consider, you know, input image is there. Okay, I'm again covering the concept in short. Okay, this is having 28 by 28, 784 neurons are required. Neurons means every value. In this every value, what exact value we will fill means the pixel value. Okay, so we understood that input layers are there. Then the second step is hidden layers. Hidden layers are actually, again, I'm saying that these are arbitrary. That means any number of neurons you can consider, and any number of hidden layers also you can consider. There is no rule. In general, we will consider one hidden layer with some number of neurons and we'll calculate the output. Okay. If we feel that output is not at all matching the actual result, even though we are trying different ways, then we will add one more hidden layer, and we will even add one some more neurons. Okay, in the each hidden layer. Okay, now you understand how to define the input layer, how to define the hidden layers, and how to define the output layer. Output layers are simply like how many values that you want to classify. For example, if there is only one value to classify, then one. Usually it can be two, or can be any number of classes, whatever the number of classes in the application. Okay, for example, if we wanted to classify a handwritten digit into 0 to 9 numbers, means there are total 10, 0 to 9. So 10 output neurons we can consider. Got it? So this is how output neurons has to be considered. Up to now, is this clear? Can I get a quick confirmation? Is this clear? The how to set the input layers, output layers, and hidden layers? Both of you? Can anyone give me a response? Thank you, Prajwal. Okay. After that, listen. After that, how actually connections are happening means there is concepts called weight. Weight. Important concept is called weight. These weights actually will help us to determine this feature. How? Means there is a formula, you already know this in logistic regression. Y is equal to mx plus c. This M value and C values are really important, right? To predict the Y value. Similarly, here also the M value, instead of M, we will be having weights, and instead of C, we will be having bias. Okay. So these weights and bias will help us to understand. Okay. Then we need to convert these continuous values to the discrete values between 0 to 9. Correct? 0 to 9. These are the classes. How do we convert these to 0 to 9 with probabilities? With the help of activation function. Thus, activation function will convert the linear property to the non-linear property. Okay. So once we convert them to the non-linear properties, we will flatten them and then pass it to the different things. Which actual neurons are get highlighted, that is the what the class will be decided. Got it? So now the question is, how do we define our outputs are really good? So there we have loss. There we have the concept of loss. We can have different loss functions, cross entropy loss, stochastic cross entropy loss. We discussed. So there are different loss functions. We will define one loss. But the goal of loss is we need to get the less loss between the difference between the actual one and the predicted one. We have to aim to get this value as minimum as possible. Okay. In order to get that value as minimum as possible, so weights are really important. So that is why what is the structure of deep learning means we will be having input layers, we will be having output layers and hidden layers. First step is forward learning. Forward learning. In forward learning, what will happen? We will get the output. We will just pass the input values and the out. Here actually loss calculation. Loss calculation is the second step. Loss calculation. If you identify loss is very high, then the third step is back propagation. This is called back propagation. In this back propagation, what will happen? The weights will get adjusted and again calculate the loss. If loss is greater, again go back, update the weights, again come back. Until unless you get the less loss, this process is repeating. Okay. Then what are the ways to calculate loss? I already mentioned there are different ways to calculate the loss. Similarly, what are the ways to update the weights is there are mathematical properties which we can update the weights. Those are called as adaptive and stochastic gradient descent, Adam optimizer. These are all RMS prop. These are all different algorithms that we can try to update the weights. Now is it clear? Now is it clear? Can I get a quick confirmation? What is the actual process going happen behind? Yeah, thank you. Fine. So now let us try to understand this concept with help of coding. In coding, anyway, you need not to worry much. Coding is really easy. So I already mentioned here what are artificial neurons, input layers, hidden layers. Okay, how exactly it mimic, and what is the purpose of the input layer? What is the purpose of the hidden layer, and what is the purpose of the output layer, and what are the different activation functions. So main things are these: sigmoid, relu, softmax. These are really important. For example, if you are doing two classes, only you are classifying between two, either yes or no, something like that, you can use sigmoid activation function. If you have faster training, if you want to know the, I mean, if you really wanted to fasten, then relu you can go for rectified linear unit. I already mentioned it always decide between 0 comma z, max of 0 comma z, or 0 comma infinity range. Softmax, if you have multi classes, for example, if you have multi classes, you can go for softmax. Then mathematics behind this, anyway, we just discussed already. You can also have a quick look on it. Okay. And one more thing, weights and biases initialization, there are different ways. One is random normal, Xavier Grolet, he initialization. All these are mathematical techniques to initialize randomly the weights. Okay. If you have smaller networks, then you can go for this. Sigmoid or tanh if you are using, then you can go for this. And ReLU, if you are using ReLU activation function, you can go for he initialization to assign the values of weights and biases. Back propagation, there we calculate the gradient, where we will get the less gradient. and we will update the weights something like this. Here you can see gradient descent approach. We will update the weights like new weight will be old weight minus step size of change in the learning rate. Okay, what is the step size? How much step we want to do? 10% or 20%? That is what learning rate, or 1%. How do we implement this in using Python means we need to understand the library called TensorFlow. Okay, we can use TensorFlow library. We can import the TensorFlow library, and just let me run this one. Here, I just wanted to fasten the process, so I'm going to change the computing power from CPU to GPU. And once I change, do remember again, you need to run from the beginning. It will take time to get connect. Once it connected, rest of the process will go very fast. Yes, it is connected T4. Now you can see very fastly we can run every cell. Okay, when compared to earlier, because now we are running in the T4 GPU. Okay. Here we can see I'm considering a MNIST dataset. MNIST dataset means the handwritten digit dataset. The university's students have collected a lot of handwritten words. Okay, handwritten digits. For example, this is one example. In training dataset, I just randomly picked one value. Third value is this one. It is the label is 5, but actually it is showing as 1. I mean, looks like 1, but according to the data set it is 5. Okay, so likewise the data set is having, you can play around with different values. Okay, you can change the values and you can get the values. And here you can see I already mentioned I just wanted to normalize it between 0 and 1. That is why I'm dividing by 255, so that I can easily normalize every value. And adding, see here it is the main important thing. Up to now what we are doing is it is pre-processing the data. Now it is what the building the neural network. What we are doing is Keras, we can use the sequential property. The first layer, this is the first layer, and with 128 neurons we are considering, and the activation function is ReLU, first hidden layer, and input size is 784 input neurons are there, and this is the first dense hidden layer. The second hidden layer, we are connecting two hidden layers here. Second hidden layer is having 64 neurons, and really I wanted to fasten the process. That is why I'm taking ReLU activation function. And the third layer, which is output layer, 10 neurons only are there. So 10 either it can be 0 to 9, means 10 things are there. I mean 10 classes are there. That is why 10 neurons are fixed at the output. And activation function, I'm using softmax. I already mentioned that if you wanted to predict multiple classes, then it is the best way to go for softmax. That is why I considered softmax activation function in the output layer, but in the hidden layers, I just consider the ReLU. Means I just wanted to fasten the process. Okay. Once you did the model architecture, this is the model architecture, right? And after that, you need to mention the optimizer. Optimizer means I just mentioned, right, to adjust the weights accordingly. And loss function, here we are considering categorical cross entropy. And metrics, we really wanted to know the accuracy. Okay, so remember one thing, the optimizer can be anything, either Adam optimizer or stochastic gradient descent or anything. You need to do iterative steps. Okay, and categorical loss, cross entropy loss, there are different loss functions also there. You can try it out one by one and then observe the accuracies. And then metrics, I just considered here accuracy, but if you are interested, you can also go ahead and calculate the precision, recall, F1 score, all such parameters. Okay, this is the architecture summary. If you give summary, this is the architecture. Okay, so this is architecture, how many parameters that what we have, and in every layer what is the happening. Okay, then here you can see how to understand this architecture. Means first one, we are having 784 input layers. Second hidden layer, first hidden layer means second layer is what first hidden layer. It is having 128 neurons with ReLU activation function. That is what it is mentioning. Okay, and second hidden layer is having 64 neurons only with ReLU. Output layer is having 10 neurons with softmax. Okay, these are the things. Atom optimizer we are using as an optimizer. Cross entropy loss we are using as a loss function. And then history is something like we are fitting the X train and Y train 64. Every update the weights after every 64 samples. After every 64 samples, we need to update the weights. That is what the batch size. And epoch means number of full passes through the data set. That is generally one time. If epoch is equal to 1, it only learned one time. At least we need to run for 10 epochs. That means 10 times we want our entire structure has to be iterate. Validation split means simply 20% goes to testing, um, and 80% goes to the training. So we need a validation split. Then we can go ahead and run this. So it will take one by one. First epoch, it is running. Okay, run. See, since I am running with T4, that is why it is taking very less time. Otherwise, you can observe in CPU or in your local machine, it will take good amount of time. So that is why if you're don't having any GPU in your machine, then you can go with the Google Colab. It will have default GPU free access for limited memory. Anyway, all the applications can come under the memory, so we can freely use them. You can see the training accuracy and validation accuracy. Here, actually, training accuracy started from here 91 to till it reaches the 99, but testing accuracy, validation accuracy started from the 96 until it reaches again 97. But here, these two are converge. Okay, we can consider that point converge. Both the points are 96, 97, something like that. And evaluation matrix, simply we will get to know the testing accuracy and loss and all. And here you can see the range we already predicted, and this value is predicted as 7, and the original value is also 7. Yes, this is predicted as 2, correctly predicted. This is predicted as 1, good. This is predicted as 0, this is predicted as 4. Yeah, everything is good because 97 and 98 is what the accuracy what we got. And go ahead and do different modifications, and then you can also try it out. Okay, and this is all about. Let me stop here.